Hello students, so today we will start a new chapter, Chemical Effects of Electric Current. You have studied in the previous class that when electricity passes through any electrical equipment, it becomes hot. That is called heating effect. Like in the room heater, in the geyser, when electricity is passed, the water becomes hot. Your TV also, if you keep it on for a long period of time, you will see it has become hot. So this is heating effect. Today we will be learning the chemical effect. Chemical effect means you might have learnt that there are two types of effects, physical effect and chemical effect. Physical effect are reversible, like if you take ice from the refrigerator, keep it outside, it will become water. You put it back in the refrigerator, with time it will become ice. But chemical effect, iron gets rusted. Now from rust you cannot get iron back. So this is the chemical effect. Due to chemical effect, your fruits becomes ripe. Is it all right? So these are called, in chemical effect, a new substance gets formed. Like iron, when it gets rusted, it forms iron oxide. We will be learning in higher classes. Okay. Now let us try to see what chemical effect take place. In chemical effect, as a new substance gets formed, so many times color also gets changed and physical form also gets changed. Let us see now how to study chemical effect. Now before explaining to the chemical effect, first let us try to revise what we know little about electric current. See, you have seen a battery. Battery has got two connections. One is at the top point and one is at the bottom. If we connect a bulb across these 2 points, the bulb will glow. So this is due to heating effect. The bulb passes electric current, the battery passes electric current through the bulb and the filament gets heated up and it emits light, or we say it glows. Now electric current is flow of charges. I am not sure whether you know what are electric charges. So I will just try to explain in very brief. Any material is made up of atoms. Atoms are made up of three kinds of particles. One are called negative charge particles, others are positive charge and others are neutral. Now what do we mean by charge? Negative charge, positive charge. I will try to explain because we have not studied much physics so far. Now you see, you might have studied magnet north and south poles. Magnet points in the north and south pole direction. So we say if we bring another magnet near to the north pole, it will get repelled. So we say that magnet produces some magnetic field around it. Now it was seen that this matter is having two types of particles. When these particles pass through a magnetic field, they behave in the opposite sense. As they are behaving in the opposite sense, so they gave one type of particle negative and other kind of particle positive. Because when these particles join one another, then it becomes neutral. So means they are having same quantity of some property which we are calling it charge, and they are opposite, because in the magnetic field we find that they are behaving in an opposite direction. If one turns left, other will turn right. So one was called negative, other was called positive. So far you can just know that matter consists of two kinds of particles. Some are negative, some are positive. Now negative particles are called electrons. So electrons carry negative electric charge and protons carry positive electric charge. How they are distributed in matter, in atom, we will study in afterwards in some in 9th standard and later on. Is it all right? So for today, to just know that there are two types of charges, negative charges and positive charges. So similarly in battery, when we say that this pole is positive and other is negative, the pole which is negative is having more of negative charge particles, and the one which is having positive is having less negative charge, so its positive becomes more. Like plus 5 minus 10 would give minus, so it will be negative charge. But plus 15 minus 10 will give me plus 5, so it will become positive charge. So battery has two terminals, one is positive and other is negative. Like you know that battery is like this. Suppose that this is a battery, then here you have got some raised head. So this is positive, and here at the bottom we connect, and this is negative. So if I connect a bulb across this is B means bulb, then the bulb will glow, because now my electrons, negative charge particles, flow from here to here. Is it all right? So if the more charges flow per second, the current is more. If less charges flow, the current is less. Now you see, from this negative towards the bulb, this is a connecting wire. This connecting wire is made up of copper, and because in this copper electrons can flow very easily, the material does not give much restriction or much blockage to flow of this negative charge electrons. So the materials, metals through which charges can easily flow are called conductors. So copper is a good conductor. So we say copper is a good conductor because electrons can easily flow through copper. Its opposite is insulator. Insulator means through which electrons cannot flow easily. Like wood, plastic, rubber, they are insulators. But all metals are conductors. Aluminium, silver, gold, copper are conductors. Okay. Now, as I told you, this positive I have connected towards the negative. So, and from negative it will current will flow through the battery. So this complete, we should form a closed loop. If my wire gets broken here, there is no connection from here to here, then current will not flow. So this closed loop through which charges flow is called a circuit. It's called a circuit. Is it okay? Now you might have done this experiment in the previous class also, that if we take a battery and this is a switch for making on and off, this is an electric bulb, and now here these are the testers. So if these testers are good conductors, so if these testers, if I touch it here, very huge current will flow because there is no restriction. But when if I put some other metal between the two, then we have tested which metal is a good conductor, which metal is which substance is an insulator, depending upon whether the bulb glows or not. If I connect some copper wire here, bulb will glow. So copper is a good conductor. If I connect a wooden piece here, it will not glow. If I connect a material made of a brass, it will glow. So it is a good conductor. So this experiment we have done for metals. Now let us do an experiment to check whether liquids also conduct electricity, means whether charges can flow through liquids. So for that, what changes I have done? These are my testers. I have taken a uh, you can say some vessel, and inside you can say made up of glass, bad conductor of heat, a bad conductor of electricity. So this is a bad conductor of electricity, and here I am taking various liquids which I want to check. I can take tap water, I can take distilled water, I am taking mustard oil, I am taking petrol. So any liquid, if I want to check whether it is a good conductor or bad conductor, is put in this vessel. Now suppose if I take tap water, then I see my bulb is glowing. So if my bulb is glowing, it means tap water is a good conductor of electricity. That is why your parents or teachers or elders might have told you many times, don't touch the walls, the switches which are with wet hands. You should never touch the switches with wet hands, because wet hands will make a good conductor. So in case there is some fault in the switch, the electricity will come up to the switch. When you will touch, it will pass through the body, you will get an electric shock. Okay. So tap water is a good conductor of electricity. So tap water, we say, conducts electricity. Similarly, if I take distilled water and do this experiment, I will see my bulb does not glow. So what does it mean? It means distilled water is a bad conductor of electricity. It does not conduct electricity. But tap water conducts. Why is this difference? Because tap water contains many salts dissolved in it. Due to the presence of those salts, it becomes a conducting liquid. Okay. Now if I add some lemon juice in distilled water or vinegar juice, then also it will become a conducting liquid. Similarly, if I add any acid, nitric acid, sulfuric acid, hydrochloric acid, acetic acid, etc., if I add any base means a thing which is soapy to touch, like sodium hydroxide, potassium hydroxide, or salt, common salt, sodium chloride, copper sulfate, barium nitrate, any of these things if I add, they will conduct. Now when I add any acid, base, salt, or when salts are present in distilled water, why do they conduct? Because we will be learning in higher classes that all these substances are made up of two radicals. One is positive charge, other is negative charge. They are combined together, like sodium chloride is made up of sodium and chlorine. Sodium is positive, chloride is negative. But when they are together, it becomes neutral. But when I dissolve in water, they separate. We say they dissociate, and sodium becomes separate, chloride becomes separate. So then those charges move. So those charges of sodium and chloride or copper and sulfate are called ions. So they are called IONS ions. They are called ions. So if any ions are dissolved in water, then water also as such forms ions, hydrogen and hydroxyl ions. So then these ions move. In which direction the ions will move? See, this is bigger line indicates positive, smaller line indicates negative. So this is positive. This is a bigger line connected here. So if this is positive, all my negative ions will move towards positive, and all my positive ions will move towards negative. Opposite charges attract one another. Like in magnet, opposite poles attract one another. In this, opposite charges attract one another. Is it all right? Now, instead of this solution, if I take sugar solution, petrol, kerosene, I will find that they don't conduct. because sugar is made up of molecule C6H12O6. So petrol, kerosene, they will be learning, does not form ions. So any substance which does not form ion will not conduct. Okay. Now milk, honey, they conduct because they contains some substances which are made up of ions. So they conduct the electricity. Is it all right? So you should learn that substances when dissolved in water, if they dissociate and form ions, then they conduct electricity, otherwise they are not conducting. Is it okay? Now, as such, the conduction of electricity or charges in flow of charges in metals and flow of ions in liquids. So this is one difference between conduction of between flow of charges between metals and liquids. In metals, electrons move. In metals, only electrons travel, and there is no chemical change. But in liquids, ions move. Positive ion will move towards the negative terminal, and negative ions will move towards the positive terminal. Here ions move, and when the ions move, so means the substance which is made up of ions has got separated into two ions, and ions have moved, and now there will be some other chemical reaction can also take place. So they are associated with a chemical change, because the material breaks up into dissociates into ions, and the ions move. So how we will come to know that chemical change has taken place? By experiment we will be seeing, like when we pass electricity through water containing some salt dissolved in it, so that electricity can pass through water, we will find that I can see bubbles of gas coming out. Okay, the bubbles that comes out at that positive terminal. We will learning now that positive terminal, this rod is called anode, and negative terminal is called cathode. Okay, so hydrogen comes at cathode and oxygen is liberated at anode. So I will find some bubbles here, and if I collect this gas and test it, it will be oxygen. Is it all right? Now in case I have taken some other liquids, mustard oil, milk, honey, some other, if the electric current is very weak, then my bulb may not glow. I will come to the wrong conclusion. So I should have method of testing weak current. I should have a method of testing weak current, so that in case it is not a very good conductor, but in between it conducts electricity to a smaller extent, then how to recognize it, how to know about it. So in that case, what we will do, we will, instead of these bulbs, we will connect LED lights. You know that now everywhere we are using LED lights. So we will be using LED lights. LED has got two long, it's a LED light. It has got this two long poles. The longer one is positive and shorter one is negative. So longer one should be connected towards the positive, and this is the LED light. So this I will put inside this. So longer one I will connect to positive and shorter one to negative. So instead of bulb, I can use here LED lights. And other change that I will do is that instead of measuring by this bulb, as I told you, now I will measure by magnetic effect. So I will take suppose this is a empty matchbox. Inside space is there. There I will put a magnetic compass needle, and this wire I will make few turns of wire across this matchbox. So where current will flow, then due to its magnetic effect, the needle will deflect. So magnetic needle will deflect when small amount of current flows. If the current is more, deflection would be more. So depending upon the amount of deflection, I can also get an idea how much is the material conducting. Okay, so I will be using now this magnetic principle instead of this heating one, because heating requires higher current, but magnetic effect is seen even with smaller current. Is it all right? So you revise this, and then I will start further about electroplating and its applications. I will give you a few minutes from the textbook. You can read up to. So let us start after the break. I hope you have understood the topic that was explained to you before the break. Now we'll proceed further. I explained to you the chemical effects of passing electric current through conducting liquids. I gave you one example of if we take water and if we add dilute sulfuric acid to it few drops, so that it becomes a conducting liquid, a conducting water. Then I explained to you, if we take two electrodes made up of graphite or carbon. Graphite is a type of carbon, so they are made up of carbon, and one is connected to positive, other is connected to negative. The electrode connected towards positive is called anode, and electrode connected to negative is called cathode. The solution in which we pass current is called electrolyte. So in this case, my electrolyte would be acidified water, and the vessel in which it is taken is called electrolytic cell, and this process is called electrolysis. So we are doing electrolysis of water. So electrolysis means breaking. So water will split into its constituent. So when we pass electric current through water, we will see that gases are getting emerged from both the electrodes. At cathode, if I collect the gas and check, it would be hydrogen, whereas at anode, if I collect the gas and verify, it would be oxygen. So means water is made up of these two gases. This is called electrolysis of water. So chemical change has taken place. Water has got, we say, decomposed into oxygen and hydrogen. Similarly, in case we have some other electrolyte, and we will sometimes see that after when we pass electric current, due to chemical changes, the electrolyte will change and its color will change. So these are the various observations which indicate that chemical changes take place. Liberation of gases, change of color of electrolyte, and we now will be learning electroplating. So there will be this seeing that metal gets deposited. So deposition of metal. So these are the three main important observations that will indicate that chemical effects take place when current is passed through conducting liquid. Now let us try to understand how to do electroplating. So this is the electrolytic cell. Here I have taken copper sulfate solution. So this is an electrolyte. I have taken two copper plates So they will act as anode and cathode. Which would be anode? Which is connected towards positive, and one which is connected towards negative is cathode. Now as soon as I switch on the current, then you wait for some time, you will see that some metal is getting deposited at cathode. You can see some small particles getting deposited at cathode. And if you take the mass of anode, you will find that my anode has become a bit thin. Okay. Now how does it take place? Let us try to understand that. As I told you, here in electrolyte is copper sulfate. So copper sulfate is made of two ions, copper ion and sulfate ion. Copper ions are positive, metals ions are always positive. Copper ion is +2 and sulfate is -2. Sulfate ion is -2. So my positive ion will move towards cathode. So I will get copper ions at cathode. Now at cathode means it is connected to negative. So here it can easily get, it is getting electrons from the negative terminal battery. So copper, which is +2, will react with this to -2 electrons and will form copper metal. That is why copper atoms are getting deposited here. Now sulfate ions are moving towards anode, but copper can easily lose electrons. So this positive end of the battery attracts electrons from copper towards it. So when now here if two electrons are absorbed by copper ion, then 2 electrons are absorbed by these positives, so that this will get balanced. And when 2 electrons are lost, so here one copper atom will lose 2 electrons and will form copper ion. So from here, from anode, copper ions will go in the solution, and at cathode, copper ion will form copper metal. So this will be the reaction, and copper sulfate will remain as it is. So in net, what is happening? Copper metal is forming copper ion at anode and getting dissolved in the electrolyte. From electrolyte, copper ion is going towards the cathode, reacting with 2 electrons and getting deposited at cathode. So this process is called electroplating, means creation or formation of a metallic layer on other metal. Now this is done, this has got various applications, like jewelry, you know, what we call it artificial jewelry, because base metal is different, and gold or silver plating is given, thin layer of gold or plating or silver is deposited on the ornament. So ornament, or wherever we want to deposit metal, that would be kept at cathode. So my ornament is kept at cathode, made up of brass or some other cheaper material, and my gold or silver will come here and will get deposited. So anode would be pure gold. So that gold ions will go in the solution, and the solution would be gold nitrate or something like that, so that my gold ions will come here. Okay. So this is also, we are using tin containers. Tin containers means containers made up of iron. I deposited tin so that I can store food in it, because my food contains acids. Otherwise acids will react with iron, zinc, with iron, and the products are not that good for eating. But if we store in tin, tin will not react with the acid of the food. Similarly, all iron bridges or iron articles are coated with zinc to prevent rusting of iron. So these are the few applications of electroplating. Also, this principle is used for extraction of metal or for purification of metals. We will be learning in metallurgy in 10th standard and so. Okay. Also, you can see this if we take a potato. If I take a potato and cut into 2 pieces, and at this white color, and if I put two electrodes, this is a potato, I am putting two electrodes, one anode, one cathode. After 10 minutes or 15 minutes, you will see, you will find that at anode a greenish blue spot will be there. So this also indicates chemical effect of electric current passing through this potato. Okay, so in terms, I will again explain. I told what is electrolyte. The conducting liquid in which electrodes are dipped is called electrolyte. Positive electrode connected to positive terminal of the battery is anode. Electrode connected to negative terminal battery is called cathode. And this electrolyte will form ion, that is called dissociation. Okay, so this completes this chapter. I hope you have understood it. If you have enjoyed it and liked my explanation, you can subscribe to the channel and like the channel. And if you, in case you press the bell icon, you will get notification when I post my next video. Thank you.